Welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from theory to equipment to practical applications to what all of our different codes and standards have to say about our electrical work. This Tech Talk is brought to you by EC&M Magazine, Electrical Construction and Maintenance. Here's what you need to do. You go to ecmweb.com, and in the upper left-hand corner, there's a drop-down menu. Very first thing on that drop-down menu, it says is premium content. You want to click on premium content, go there and sign up for the premium content. It's free, and you'll get tons of information, not only on the topics we're going to talk about today, but everything to do in the electrical industry, all right? So you want to make sure you do that. I'm Randy Barnett. I am the presenter, obviously, for today's presentation. We're going to be talking about conduit today. My background is I'm an industrial electrician by trade. I've worked in various industries as a journeyman, teaching, writing books, commercial industrial wiring, and so forth. And anyway, here I am today. Now, this Tech Talk today is brought to you by Champion Fiberglass. They're our sponsor for today. They are the electro industry's answer to heavy, costly conduit. What do I mean by that? Engineers across industries and applications are increasingly specifying it's an innovative, cost-efficient epoxy fiberglass is what it is. It's electrical conduit. Champion Fiberglass manufactures this Type RTRC conduit. It gives you all the strength and durability represented by other end-market solutions. It also features a lower material cost and a lighter weight. Hey, that means saving money for you out there. So let's get started. I'm going to, as we go through these conduits today, first I'll show you. Now, you can't read this, of course, but if you were to take a look at my code book, you will find down the columns, I have some red lines, and in the table of contents, I'm on what, page 3 of the table of contents, and it starts with Article 342, which is intermediate metal conduit, and I run all the way down that page and over to the next page, all the way up to Article 3 through Article 362, which is electrical non-metallic tubing, type E&T. So from Articles 342 through 362 are our conduits, our circular raceways. Some are metallic, some are non-metallic. We're going to take a look at those. Now you go, man, we'll go through and we'll read them and talk about them a little bit, and then we'll take a look at the information. You can say, oh man, that's going to take forever. If I need to find out something, I mean, you know, where can I use electrical metallic tubing and where can I use it? And what about this RTRC conduit? Where can I use that? Where's it practical for me and so forth? Or how about rigid conduit? Where can I not use rigid conduit, huh? We'll find that out today. Well, rather than go and look through all of those articles and thumb through them trying to find information, what we're going to find out is that you just go to the appropriate article, and they're all laid out the same way. So whether I'm looking at rigid conduit, electrical metallic tubing, PVC conduit, liquid tight, flexible, non-metallic conduit, or something like that, they're all laid out the same way. If I want to know where I can use PVC, the answer is going to be in the article on PVC conduit in section .10. Section .10 will always tell me where I can use something, and .12 will tell me where I cannot use that particular conduit. My support requirements are in .30. Now, each one of these conduit articles is divided up into 3 parts. Part 1 is general information. Part 2 is my installation requirements. And that probably is what pertains to us for the most part, isn't it? Installation requirements. And then part 3 is the construction specifications for that particular type conduit. So let's just run through this list, talk about them a little bit, then we'll go into more detail and find out what's in these articles and what information I can use to apply, select, use, size, install the proper conduit that I need in the field for the job. Huh? So I mentioned I said 342. Article 342 is intermediate metal conduit, or type EMC. If I told you this was IMC conduit, intermediate metal conduit, you probably couldn't argue with me because this is not true. This is actually rigid type RMC conduit. They look the same. The difference is the intermediate metal conduit will have a thinner wall to it than the rigid conduit. And but it takes the same fittings. You know, I can put the same fitting on a piece of on a piece of you know, IMC or rigid. It's going to work the same way for me. Okay. So IMC and rigid conduit. Now I told you that IMC, or excuse me, I told you that for all of our conduit raceway articles, we find dot 10 is uses permitted and dot 12 is uses not permitted. But if I go to IMC conduit or Article 344 on rigid metal conduit type RMC, I don't find any section dot 12, uses not permitted. The reason is I can use IMC and rigid wherever I can use conduit. Okay, so there are no limitations. Now, Article 348 is on flexible metal conduit type FMC, and you may see that up in some overheads above suspended ceilings. And Article 350 is on liquid type flexible metal conduit type LFMC, liquid type flexible metal conduit. This is non-metallic conduit, but if it had the metal on the inside, the metal spiral, it would be metal. Okay. So anyway, we use a lot of liquid type conduits, don't we? Both the liquid type non-metallic and the liquid type metal conduit we use a lot for we're subject to vibration, movement, and so forth. Think of connections to motors is very common where that motor vibrates. Huh? So we use our flexible conduits for that. So Article 350 is on LFMC, liquid type flexible metal conduit, and Article 352 then jumps up to type PVC, rigid polyvinyl chloride conduit. So our PVC conduits that we're, probably familiar with. Now the things to pay attention when you're working with PVC conduit. If I'm going to put my PVC conduit somewhere where it's subject to maybe some pretty severe physical damage, I'm probably want to go to a heavier wall conduit. And so that's what we've got here. We've got two different types. This is says Schedule 80 on it, and this other one is Schedule 40. So the difference with the Schedule 80 is it's a little bit thicker wall than what the Schedule 40 is. So if it's going to be subject to physical damage, I think I'd be better off to use my Schedule 80. And of course, that's what the code's going to tell me as well. However, even though it's a thicker wall, it's the same. I use the same fittings for all that PVC conduit, you see, whatever trade size it is. By the way, this is what? Let's see. It says Schedule 80, extra heavy wall, rigid. It's listed. It's listed. If I go to section .6 and all of my conduits, it says they have to be listed. In other words, listed by a nationally recognized testing lab. Most commonly for us, that's either going to be UL, CSA for Canadian standards. So this one is listed. This is some 3/4 inch conduit, 3/4 inch PVC, by the way. So there are going to be different support requirements for my PVC based on the length, the size of the conduit, and then of course, the spacing between the different supports will be specified all in the tables, and that's true from all of my conduits that I support them. Okay? So Schedule 80, Schedule 40, just the difference in the thickness. Pay attention to your code book on PVC conduits when you use them as to what schedule conduits you need them. 353 is high density polyethylene conduit. That used to be part of, we used to call rigid non-metallic conduits. Oh, I think it encompassed what, HDPE and PVC and so on, but now those have all been broken out in more recent code editions. 354 is non-metallic underground conduit with conductors. So it's a non-metallic conduit. I can put it underground, but it already comes with conductors on the inside of it. So it makes my installation process quite a bit different then. Now, type RTRC is what we're going to talk about in a little more detail, some of the specifics on it. And we can find type RTRC, that's Article 355, fiberglass conduits in. 356 is liquid type flexible non-metallic conduit. So LFNC, type LFNC. And this says what? It says, oh, well, there's my NRTL listing on it. And it says outdoor direct burial, sunlight resistant. Oh, if I'm going to expose some type of PVC like this conduit, this is, of course, a flexible liquid type non-metallic, but similar material. If I'm going to take and expose my non-metallic conduits to the direct rays of the sun, it's got to be marked sunlight resistant. Okay? Also, if I'm going to bury it directly in the earth, it's got to be direct burial, listed for direct burial then. And let's see, where do we leave off? Okay, Article 358 is electrical metallic tubing, type EMT. And actually, part of the definition, it uses the term thin wall, and we often just refer to this as thin wall. Go get me a stick of thin wall, you know, or something like that. And this has a set screw coupling on the end of it right now. Very commonly used are set screw couplings. Goes together fairly quickly, obviously, and easier to bend than a rigid conduit and so forth. And flexible metallic tubing type FMT is Article 360. And then 362 is electrical non-metallic tubing type ENT. Type ENT, that's that corrugated conduit that we have, fairly flexible, smooth wall on the inside, and makes installation a little bit easier then. So type ENT conduit. So those are our different conduits. Let's go through now, talk about a couple of things. One is that I can get fittings, whatever I need pretty much, right? Okay, so even something like this rigid conduit, there are different types of bushings. 300.4 tells me that on 4-gauge enlarger, isn't it? That if I pull a 4-gauge enlarger through a conduit, I have to have a bushing on the end of it to protect it. This is an insulated plastic bushing is all it is. This is a grounding bushing, right? So I can put this bushing on this end of conduit, and I've got a set screw here. I can tighten that screw down, and I can get really good bonding, can't I? Then I can run my equipment grounding conductor, bonding conductor, through here and bond to wherever it is that I'm going from that point. So there's different fittings I can buy. I can buy a reducing washer. So let's say that I want to, this is 3/4 inch, and I need to go up to 1-inch conduit, or come down from 1-inch conduit, whatever I'm doing, right? And so now I can take my 1-inch conduit and screw it right onto the 3/4 inch. I have to get proper thread engagement. I have to get it tight enough. If I don't have it tight enough, this is pretty loose actually right now. I don't know if you can see that, but I can shake that around and wiggle it. That's not good for bonding, okay? So I need to make sure that I get it tightened properly, wrench tight. And so wrench tight, if you take a look in the other standards that talk about installation of conduits, the National Electrical Installation Standards from NECA, the NEMA standard for conduit installation and so forth, you'll find specific information on how to tighten the different conduits in. Okay? Things like, you know, I can take, right, and I can put this is called an LL, okay? And the reason I say I'll pull the cover off here, but you know, the thing is, well, if you hold it like a pistol and the opening's on the left-hand side, that's an LL. Here's an LB. The opening's on the top. If the opening were on the right, it would be an LR, so forth. Anyway, now, can I splice inside of this? And the answer is yes, if I know the volume on the inside of it. And so I take a look on the inside, and sure enough, in here somewhere, it tells me, or maybe it, oh, here it is, it's on the outside, volume 7.3 cubic inches. So that allows me to go ahead and splice conductors on the inside of this. So facilitates pulling. It also provides me a place I can splice my conductors. Now on this just simple little pull elbow here, it's just simply to facilitate pulling. There's no volume marked on here. I cannot splice inside of here. And so this is just a PVC pull elbow then, and makes life a little easier when we're pulling wires through it. Okay. So those are my different types of conduits, an example of some of the accessories I can get. To find out what the information is then in these different articles, what types of information we can find, let's go in the back to Article 355. So in your code book, if you've got your code book handy, you can go to Article 355, which in your 2020 NEC, which is what I'm using, my 2020, okay? Article 355 is found on page 215. Now, so let's take a little look at Article 355. It's representative of what we're going to see on all the other articles. Article 355 is on type RTRC conduit, and that stands for reinforced thermosetting resin conduit. You and I probably call it fiberglass. Okay? And so part one, general information, tells me Article 355, what it covers. 350.2 will give me the definition of what RTRC conduit is. Then it starts into part two. Oh, dot 6, I'm sorry, it's my listing requirements. So I said our conduits are required to be listed. Now, part two is installation. 355.10 is going to talk about 9 uses where I'm permitted, or 9 installations where I'm permitted to use type RTRC conduit. So for instance, I can use it concealed and corrosive, where it's subject to corrosive environments, under cinders, in wet locations under certain provisions, damp and dry locations, certainly, where it's exposed. And if you don't know what exposed means, go to Article 100 and look up the definition of exposed. And underground installations, I can use it. I can use it to support certain non-metallic conduit boxes and things like that. And there are insulation temperature limitations also covered, talking about the conductors that I put on the inside of it. So anyway, well, I can also run cable through my conduit as well, can I? Uses not permitted. There are 5 uses where I'm not permitted. So this is dot 12. Dot 10 is permitted. Dot 12 is not permitted. With provisions, I am allowed to use this in hazardous classified locations. So I need to look in the NEC article and find out what those provisions are then. Make sure you follow those. I don't want to use it for support of luminaires. Pretty heavy fiberglass conduit. Physical damage, we're subject to physical damage. It has to be marked XW. Now this is marked AG, so that tells me it's suitable for above ground, not underground in this particular piece. It's above ground, and if it were marked XW, that would tell me that I can use it where it's subject to physical damage. And theaters and similar locations. I can't use it that except as provided in the articles on theaters. So that's kind of interesting. Anyway, so I'm going to go back to chapter 9 and use my tables in order to size my conduit, of course. So what size conduit I need, in other words, based on the size, the number of conductors, and their insulation. And so anyway, that's back in chapter 9. It covers bins, how my bins are made, in dot 24 of a section of an article. For the RTRC, I have to use a PVC hot box, follow manufacturer's instructions in, right, on how to bend it. I have to trim the edges of it and so forth. It tells me once I cut it. I have to securely support it. And that is based on the table that you'll find for the different articles as to the size of the conduit and the length of the run and so forth, and how close to it is to a box and so forth, how often I have to have my supports in there. Okay. Bushing requirements we've talked about. Expansion fittings. If I'm going to use an expansion fitting, I have to follow manufacturer's instruction. Fiberglass conduit does expand somewhat, and so I've got to install my expansion fittings properly, and so that the conduit can move and not crack or break or anything like that after I install it as temperatures change. Grounding. Well, this is, depending on the conduit. Now, things like a lot of my metal conduits, like my rigid, for example, I'm allowed to use that as my equipment grounding conductor. Even though, granted, today, quite often we pull through that equipment grounding conductor as well. If I'm going to use something like a non-metallic conduit, gosh, I guess I better install an equipment grounding conductor in here, because certainly the conduit's not going to provide that feature for me then. And then part 3 gets into the construction specifications. And depending on the the type of conduits you have and so forth. It's going to spell that out for you. So for instance, in the fiberglass conduit, it talks about being above ground, it's flame retardant, resistant to impact and crushing. For underground, it has to be acceptably resistant to moisture and corrosive agents, and so on and so forth. Also, when I'm going to join this conduit together, the code tells me in this article that it has to be done by an approved means. And what does that mean? Well, that means acceptable to the authority having jurisdiction. You know, as an electrical inspector, I don't know everything there is to know about all the conduits in the world and so forth. So we're going to rely on manufacturer's instructions. So the manufacturer provides us for this particular RTRC conduit some epoxy that we're going to use. If I go to their website, there's videos that tells me how to use this. And so it's pretty simple. I'm going to, you know, dress the end of my conduit first and get probably going to have me take some memory cloth or something like that and clean it up and so on. And then I'm going to go ahead and apply my epoxy according to the manufacturer's instructions. And then I can take, and I'm going to this box connector, for example, I can go ahead and attach together and however the manufacturer tells me to allow it to cure them. So lots of information on conduits. Okay. What I would encourage you to do then is to go through Articles 342 through 362 in the National Electrical Code. Just run some through them and take a look and think about where you could use these different conduits. Dot 10 and dot 12, of course, is going to help you with that. And think about the use of RTRC conduit as well. As I mentioned earlier, it's strength, durability, and cost, and time for installation, and so forth, are all things that you need to consider, no matter what type of conduit you're going to use them. Okay? So anyway, that's all the time that we have. Get back in your code book, highlight some areas that you need to. And of course, we want to make sure that you go to the ecmweb.com, sign up for premium content. And also we want to thank our sponsor today, Champion Fiberglass.